Next, we're going to talk about is adding an extra constraint. Okay? If I add another constraint, and this we use quite often in practice, we're adding additional constraint, a rows of A, n plus 1 times x less than or equals to b plus n plus 1. So it's adding to the bottom of your simplex Tableau. If we have a previous optimal feasible solution, it satisfies the extra constraint, then the current solution is still optimal. If not, okay, we need to adding this, otherwise we must adding this extra row to the table. So what's going on? So now the P is n plus 1, for example, and the current basic feasible solution and the Tableau gives, actually, you see this really easy, xb, which is the current basic variables, plus b inverse times n times xn, which is non-basic variable, currently 0, equals to b inverse times b. Also, adding the extra constraint, which is a b over p, p is n plus 1 at this point. So just using the portion of origin n plus 1 times xb, the corresponding xb, the a p over n on a and p times xn. So it is just that particular row I separate or reorganize into xb and xn. Plus, since this is less than or equals to constraint, I'm adding a slack variable right here, and this is the new right hand side in the constraint, so it's b times bp. Alright, so what I do is I'm going to multiply equation number 1 both sides by ABP. So here I'm going to multiply ABP, and also multiply by ABP. And move this thing to the right hand side. Okay, move these things to the right hand side. So XB will be equals to B inverse times B times minus B inverse times N times Xn, and times ABP, of course. And then we'll plug in XB into what? Replaced by B inverse times B minus B inverse times N times Xn times ABP, for example. Then we only collect Xn term right here, plus the slack variable, and the right hand side also change. Okay? So I'm going to do it right here, slightly. You see that? If I multiply ABP, 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 ABP on both sides of equation, and this becomes XB equals to B inverse times B minus B inverse times N times Xn. I'm going to replace this, okay, to this equation. Since I have ABP everywhere, okay, I'm going to replace this in equation 2. Okay, and then I'm going to collect only the xn in the left hand side, collect only the xn in the left hand side. So this will be ABP times B inverse times B, right hand side B, minus B inverse times N times Xn plus AMP times Xn plus S equals to BP. All right. Then we're going to continue right here in the empty space. Sorry, getting out of the way for you. So this will be equals to collecting the xn term and moving this terms already, since this is constant, moving to the right hand side. So that will have ANP, which is this part, okay, minus ABP times B inverse times N times XN. So it's ABP times B inverse times N, these two, times XN equals to, plus S equals to BP minus this term in the front. ABP times B inverse times B. All right. So this is what happened in the second equation down here. So both of them has to maintain, okay, 0 or positive. If this is the case, if the right hand side still maintains 0 and positive, and then it's still optimal. Otherwise, I'm going to produce a negative. So if it's negative, we're going to perform a do simplex method. Because xn right now, the xn right now equal to 0, xn equal to 0. So this terms and both equation will be equals to 0. So the current basic solution, xb equals to b inverse times b, okay? And s equals to, s is the slack variable, equals to this right hand side. bp minus abp times b inverse times b. So we create a current basic solution equals to xb plus s, because s currently is the default basic variable. If the right hand side is, both of them are still non-negative, hey, we're fine. If some of them are negative, then we'll do a do simplex iteration. Let's look at an example. Next iteration. Adding a, so this is what I have is summarized from the previous, okay? So we still have row 0. I separate them with a xb, which is the current basic variable, xn, current non-basic columns. And in the optimal tableau right now, the this portion will be identity matrix, and this portion will be B inverse times n, okay? And on top will be Zn minus Cn for the non-basic variables, all of them. Supposedly should be less than or equal to 0. And this is right hand side is the optimal, this currently optimal objective function value, and this is the current basic solution. Since we're adding the new constraint on the bottom in the green area, there's one rows only. This portion will be 0. Okay, I want, since right now maintain this identity column, and this the non-basic column portion, non-basic column version, non-basic row version will be equal to this. Okay, and currently S is the default basic variable for this new constraint, and then the corresponding right hand side. We just have to check if they are non-negative. Okay. Give an example real quick. Okay. And look at the optimal tableau right here. Okay. The optimal tableau is all the Zj minus Cj elements are non-positive. Right hand side all positive. So it is primal and due feasible at this moment. if we're adding a new constraint, x1 is less than equals to 1, in this case, of course we know the current basic solution, these two, okay, x2, especially x2, is not satisfying the additional constraint. Okay, we just added it. So what we do is we adding a slack variable for called x5 into our model, and so x1 plus x2 plus x5 equals to 1. Make a equality and add this row to the bottom of the Tableau. So take a look right here. This will be the new Tableau, okay, with this column added. So here what we have is what? x2 plus x5 equals to 0, added to here. Since currently x2 is the basic variable, and now that this column A2, y2 is no longer identity, so we need to perform pivot to make it identity column. So what we do is taking this this row multiplied by -1 added to the last row in order to make this guy to be 0. Okay. So after performing, we understand currently the x5, which is a slack variable, equals to a -26/19. So it's primal infeasible solution. So what we do is we're going to perform a do simplex iteration. Let x5 leaving the basis, and based on this row, what we only have one negative entry. Okay, so this x3 is actually incoming for sure, because the other ones are positive. The other ones are positive over here. We don't care. We only look at in a do simplex method, we only look at the negative elements on that row. So after the pivot, okay, x3 entering the basis, x4 and then x5, okay, are non-basic, and all the zj minus cj are non-positive. All the right-hand side are non-negative. So we know we have the new optimal Tableau solution. This concludes this part of the sensitivity analysis. And the next lecture period, we're going to start talking about parametric analysis as a little bit more involved analysis. We're using new video to explain that. Thank you.